My dear students, in the previous video, we solved some problems by using the concepts on hyperbola. That is, as foci, directrices are given, we have determined the equation of hyperbola and vice versa. Equation of hyperbola is given. From that equation we can find center, vertices, foci, directrices of the given hyperbola. These are the problems we have solved in our previous video. Now, the next concept is parametric form of different conics. What are the parametric equations of different conics? So far we are seeing some four conic sections, that is circle, parabola, ellipse, hyperbola. Circle with center origin and radius A unit. If it is the case, circle with center origin and radius is A unit, and the parametric equation of that circle is x equal to a cos theta, y equal to a sin theta. The parametric equations of circle with center origin and radius A unit is x equal to a cos theta, y equal to a sin theta. The parameter is theta, and that parameter lies between 0 to 360 degrees, that is 0 to 2 pi. Theta lies between 0 to 2 pi. The parameter theta takes the values from 0 to 2 pi. The any point on the circle is a cos theta, a sin theta. Next conic is parabola. The parabola parametric equations are x equal to at square, y equal to 2at. X equal to at square, y equal to 2at, where t is the parameter, and the t lies between minus infinity to plus infinity. T takes values from minus infinity to plus infinity, and any point on the parabola is at square, 2at. Similarly, for ellipse, parametric equations are x equal to a cos theta, y equal to b sin theta. A is the semi-major axis and b is the semi-conjugate axis. X equal to a cos theta, y equal to b sin theta. A is semi-major axis, b is semi-minor axis. Semi-major axis, b is semi-minor axis. X equal to a cos theta, y equal to b sin theta are the parameters of ellipse, where theta is the parameter, and that theta lies between 0 to 2 pi. So any point on the ellipse is a cos theta, b sin theta. Similarly, for the case of the conic hyperbola, parametric equations are x equal to a secant theta, y equal to b tan theta. Here a is semi-transverse axis and b is semi-conjugate axis. X equal to a secant theta, y equal to b tan theta, where theta is the parameter and theta lies between minus pi to plus pi. Since x is a secant theta, y equal to b tan theta, theta lies between minus pi to plus pi, except the theta value plus or minus pi by 2. Theta should not be pi by 2, plus pi by 2 or minus pi by 2. Except that, theta lies between minus pi to plus pi, and any point of the hyperbola is a secant theta comma b tan theta. These were the different types of parameters of the conics. Now, see, these any point on the circle satisfies the equation. That's why these are called parameters of the respective conics. For example, see, the range of the parameter is this. See, this a cos theta comma a sin theta is any point on the circle. The circle with center origin, this is the center origin. The radius is a unit. It is radius of the circle. This is A unit. Therefore, any point P on the circle is A cos theta, comma A sin theta. So any point on the circle. So the equation of the circle with center origin radius U, A unit is equation of the circle is x square plus y square equal to A square. This equation satisfied by these parameters. X is A cos theta. So A cos theta whole square for x square. Y square is A sin theta the whole square equal to A square cos square theta plus A square sin theta whole square is sin square theta. If you take A square as common term, you will get cos square theta plus sin square theta by trigonometry. Cos square theta plus sin square theta. Cos square theta plus sin square theta is 1. So A square into 1 is A square. So x square plus y square is A square. We proved that. Right hand side. X square plus y square is A square. X is A cos theta, y is A sin theta. So like that, any point on the circle satisfies the equation. Similarly, any point on the parabola is also satisfies the equation of parabola y square equal to 4ax. General type of parabola. See, y square equal to 4ax is the parabola. This is the parabola with the vertex is origin. Here, P any point on the parabola is 80 square comma 280 given. This equation, this point is also satisfied by this equation of parabola. Y is 280. So y square is 280 whole square equal to 4a into x is 80 square. So squaring 280 whole square into 2 square is 4. A square t square. 4a square t square. Again here 4a into a square t square. 4a square t square. Left hand side equal to right hand side. So equation satisfied by these parametric equations. Equation of parabola satisfied by the parametric equations. Like that, the points on the circle and parabola are satisfied. Similarly, the point on the ellipse and the hyperbola is also satisfied by the equation of the ellipse and hyperbola respectively. We will see. Okay. Equation of ellipse is equation of ellipse x square by a square plus y square by b square equal to 1. So the parameters a cos theta for x is a cos theta whole square by a square plus y is b sin theta the whole square by b square. This is on squaring you get a square cos square theta by denominator is a square. A square cos square theta by a square plus b square sin square theta on squaring you will get by b square. B square sin square theta, a square cos square theta, a square cancel, b square cancel, both numerator and denominator, you will get cos square theta plus sin square theta which is equal to 1. The equations of the ellipse is satisfied by a parametric equation. Similarly, equation of hyperbola. Equation of hyperbola. You know x square by a square minus y square by b square equal to 1. X square by a square minus y square by b square equal to 1. From this x is a secant theta. Substituting its respective parameters for the values of x and y in the equation of hyperbola. They replace x by a secant theta whole square by a square minus y is b tan theta the whole square by b square. this is equal to a square secant square theta by a square minus b square tan square theta by b square. A square both numerator and denominator, b square is cancelled. You will get secant square theta minus tan square theta. Secant square theta minus tan square theta by trigonometry is result 1. Secant square theta minus tan square theta is 1. Therefore, that equation is also satisfied by the parameters of hyperbola. Okay, that's all. We have to check like that. These are the parametric equations for the respective conics. Next, I am going to find out the equation of tangent to the parabola at the point x1, y1. Now, our next idea is finding the equation of tangent at x1, y1 to the parabola y square equal to 4ax. Now, equation of tangent to the parabola. Equation of tangent to the parabola y square equal to 4ax. Equation of tangent to the parabola y square equal to 4ax at the point x1, y1. So x1, y1 is any point on the parabola. We have to find out the equation of tangent. For that, you take this diagram. This is the parabola y square equal to 4ax. And in this parabola, I can find a point P, x1, y1. Now I am going to find out the equation of tangent at the point x1, y1 to this parabola y equal to 4ax. Origin is the vector x. Suppose I can take a chord Q, PQ. Q is the point x2, y2. First I am going to find out the equation of the chord PQ, and then from that I am going to convert that chord into tangent. So P and Q are 2 points x1, y1, P x1, y1 and Q x2, y2 are any 2 points. P x1, y1 and Q x2, y2 are any 2 points on the parabola y square equal to 4ax. Now slope of the chord PQ is slope of the chord PQ. Slope of the chord PQ is y2 minus y1 by x2 minus x1 is the slope. y2 minus y1 this is the slope of the chord PQ. P and P x1, y1, Q x2, y2 are into point joining the chord PQ, and the slope of the chord is difference in y coordinate by difference in x coordinate. but P x1 is a point on the parabola. P x1 is a point on the parabola. Therefore, y1 square, substitute the point on the parabola, y1 square equal to 4ax1. Similarly, Q x2 y2 is a point on the parabola, y2 square, instead of y, you get y2 square equal to 4ax2. So y2 square minus y1 square, subtracting 2 from 2, subtract 1, y2 square minus y1 square equal to 4a, subtracting 2 minus 1. y2 square minus y1 square equal to 4a into x2 minus x1. This is on simplifying y2 minus y1 into y2 plus y1 equal to 4a into x2 minus x1. From this y2 minus y1 by x2 minus x1, we bring this right hand side x2 minus x1 to the left hand side. I get y2 minus y1 by x2 minus x1 equal to, from this you bring this x2 minus x1 to the left hand side, that is y2 minus y1 by x2 minus x1 equal to 4a by this y2 plus y1 goes to the right hand side, it becomes the denominator, y2 plus y1. So instead of the slope y2 minus y1 by x2 minus x1, we can replace 4a by y1 plus y2. So slope of the chord PQ is y2 minus y1 by x2 minus y1, it is replaced by 4a into y2 plus y1. So using the slope and the point xy, we can find out the equation of the chord PQ. Let xy be any point on the parabola. Now the equation of the chord PQ is, okay, slope is this. Therefore, equation of chord PQ using the slope 4a, therefore slope of the chord, slope y2 minus y1 by x2 minus x1 equal to, what is that, 4a by y1 plus y2. So you did not write down the area. Here is the step 4a by y1 plus y2. Now the equation of the chord PQ. The equation of the chord PQ with the slope 4a by y2 plus y1 is y minus y1 equal to m. M is slope 4a by y2 plus y1 into x minus x1. So equation of the chord PQ is y minus y1 equal to 4a m, y minus y1 equal to m into x minus x. So that is the slope of equation of the chord having slope 4a by y1 plus y2 and passing through the point x1 y1. So equation of the chord PQ is y minus y1 equal to 4a by y1 plus y2 into x minus x1. Now this chord PQ becomes the tangent when the chord PQ becomes the tangent if it moves along the curve like that. Here, if the point Q moves along like that, the chord Q, the point Q moves along the curve and coincides with the point P, it becomes the tangent. If the chord Q moves along the curve like that and Q coincides with P, the chord PQ becomes the tangent at P. So, if the point Q moves along the curve and coincides with the point P, if it is so, the chord PQ becomes the tangent at P. If Q coincides with P, if Q coincides with the point P, the chord PQ becomes tangent at P. The chord PQ becomes tangent at P. That is coincide, means X2 coincides with X1 and Y2 coincides with Y1. Therefore, equation of the tangent at P x1 y1 to the parabola is x1, y is coincide with y, y2 is coincide with y1, x2 is coincide with x1. Therefore, here you get, therefore the equation of the tangent at P. Therefore, the equation of the tangent at P, tangent at the point P is y minus y1 equal to 4a by y2 is coincide with y1, therefore it is become y1 plus y1 because y2 is coincide with y1. So y2 plus y1 into x minus x1. So y minus y1 equal to 4a by 2y1 into x minus x1. Cancelling 4 divided by 2, you will get 2a by y1 into x minus x1. Left hand side y minus y1. Y minus y1 equal to 2a by y1 into x minus x1. This is the equation of the tangent at P. And multiplying y1 with this, left hand side you get y1 into y minus y1 equal to 2ax minus 2axy. Multiplying y into y1, y1 into y minus y1 equal to 2a by y1 into x minus x1. This 2a by y1 is the slope of the tangent. Slope of the tangent is 2a by y1. You remember, this is the slope of the tangent. Okay. Now this equation, further simplification, you will get y multiplying, okay, multiplying with y1. See. See y1 minus y1 into y1 is y1 square equal to 2ax minus 2axy. So you know y1 minus y1 square is 4axy because the point is on the y1 x1 is on the x1 even is a point on the parabola, therefore y1 square equal to 4axy. So y1 square is replaced by 4axy. 2ax minus 2axy. So y1, you keep y1, the left hand side itself, you bring this 4axy to the right hand side. This is 2ax plus 4axy minus 2axy. So this is 2ax plus 4a minus 2axy is 2axy. So y1 equal to 2ax plus 2axy. If you take 2a as common term, you will get the equation of tangent at P. That is y1 equal to, taking 2a as common term on the right hand side, 2a into x plus x1. So y1 equal to 2a into x plus x1 is the equation of the tangent at x1 y1 to the parabola y square equal to 4ax. y1 equal to 2a common, you can take common, you will get 2a into x plus x1. This is the equation of the tangent at x1 y1 to the parabola y square equal to 4ax. y1 equal to 2a into x plus x1. Okay, I will stop here and I will continue the lesson in the next video. You remember this book code. Slope of this tangent is 2a by y1. Remember, slope of the tangent is 2a by y1. From this expression I am getting that slope is 2a by y1. Thank you.